Notarization of digital objects from files to database records is foundational infrastructure for critical services and data. And in today's demo, I will show you that our mobile app, Carpe, can notarize data streams from BLE devices, Bluetooth Low Energy devices. We will be using a multimeter for demonstration purposes. Carpe is also available for desktop, and if you want to know more about our cryptographic notarization infrastructure, you can go to provable.dev. We are now in our Carpe mobile app, where we can create the data structures we need and pair them with various data sources like barcode scanners, GPS readings, or BLE devices. And this is a table that I created for this test, our test BLE table. And right now it has only one row that I added. And in our internals, we can look in D types, and we will see this data type that is associated with our DB1 database and our test BLE table. And it has one row right now. What this means is that for each record in our test BLE table, a notarized record will be created in the app, more specifically in the S32 hashes table. And we can see this table here, and it contains one row of the data type that we just saw earlier. This is the notarized record of our record from test BLE table. And for each 256 records in this S32 hashes table, we will see one record registered in our Kairos system. Right now, there are only 3 records. We could register each record on Kairos if we wanted to, but we can also have this local offline notarization process on device. So next, we can go to, and also we have the change summary, what happened for each record, and the data item is the hash of the original record. So now we can go to automations, and let's remove this automation and add a new one. So we link it to our DB1 database and our test BLE table. And let's see if it finds our Bluetooth connection for this multimeter. This is it. We need to select the right service and characteristic, and we will go with notify. So this means that the device will send the app all of its readings. And we will use this multimeter decoder so we can actually see the values in a human readable format. So right now, if we listen for sample notification, we get this auto value that we can see on the screen. So let's make it read something. Okay, and now click listen again, we get this actual value here. So these values that will come in a data stream will be stored in the field called value of text type. And we will say, let's store the parsed value. So it will only have this parsed value directly. And let's select string here and save. The automation is already going. So if we go to our table, we can see 18 rows, 22 rows, and so on. So let's see. All of them have auto because this is what is read right now. But let's make it actually read some values, and now we are seeing the actual values coming in. I'll move a little just so we can get various readings here. And we want to go over 256 total rows here so we can see the records also being notarized on Kairos. Okay, now we can stop the automation. So we go back to our table, we have 300 rows. So now in our S32 hashes, we also have 300 rows because each of those records has been notarized. So now let's see and refresh here. We need to refresh the page and select our correct data type, and we see the fourth record, which notarizes this internal chain that was created inside the Carpe app. Now in this S32 hashes table, it is clear that there is no original data information. So data is notarized by hashing and a cryptographic proof of inclusion is composed. So now your BLE devices with critical data can be notarized at record level.